Okay, before we go on too far, I want to make sure to kind of get a review in, and we'll review basically what we've covered on the two circles that we've seen. So looking at the instructions at the top, find the degree or radian equivalent for the given angle. So I've got 4 angles here. We have also learned how to do this in Algebra 2. And in Algebra 2, when we did this, we used a very simple calculation. Just to remind you of that, it looks something like this. If we wanted to convert from, for instance, with number 1, if we wanted to convert from radians to degrees, we would multiply our original value times 180 over pi. And that was 180 degrees over pi. If we wanted to if we wanted to convert from degrees to radians, we would multiply by pi over 180. And now we can kind of see where that comes from. We see that 180 degrees is the same as pi radians and vice versa. So really this is equivalent measurements in the numerator and denominator. And when you have a value divided by itself, which these two are, you're just multiplying by 1. It's kind of a very elegant solution to converting these things. That's what we did in Algebra 2, and we could do that here, but now, given what we know about all this information, since we know, how these unit circles work, just kind of reviewing through those, pi over 4 and pi over 6, we shouldn't need to pull out a calculator. We shouldn't need to revert to those ratios when we're multiplying, or multiply by those ratios to do this. We should be able to do this simply by thinking about the unit circle. And this is kind of where we want to get to. We want to get comfortable enough that when we need to find degree equivalences or radian equivalences, we can just use our knowledge of the unit circle to convert those. The better we can do that, the easier it is to move forward. So I'll show you kind of what I do with this. First of all, pi over 3, I know at this point pi over 3 is on the pi over 6 unit circle. That's just from familiarity with that circle. So pi over 6 unit circle looks kind of like this. Sometimes I'll start out these types of problems by just drawing the appropriate circle. Now I know pi over 3, I'm thinking to myself, pi over 3 is on the pi over 6 circle. So it's going to be something over 6. Well, 1 pi over 3 is the same as 2 pi over 6. So on the circle, where is that? Right here, that's 1 pi over 6. Right here, that's 2 pi over 6. So I'm thinking to myself, okay, that's 2 pi over 6, which is the same as pi over 3. I've got that stored away in my head. And really I am doing that just by memorization more than anything. So I've got pi over 3. How many degrees would that be? Well, I need to remember that the pi over 6 circle, each of these angles is 30 degrees. That's easy enough to remember when you have the picture of it in your head. 90 degrees is the first full quadrant. Split that into 3 equal parts. That's 30 degrees for each part. So 30 degrees for the first part, 2 of them together, of course, that's going to be 60 degrees. So pi over 3 is the same as 60 degrees. Pretty nice. Let's move on to the second problem. 210 degrees. Now, 210 I know is a multiple of 30. 210, so if I just think about that, just that alone, 210 I know is a multiple of 30. 3 times 7 is 21, so 30 times 7 is 210. I'll say that again. 3 times 7 equals 21. So 30, which is the number of degrees we have on the unit circle for the pi over 6 portion, 30 degrees times 7 would be 210 degrees, which is what we want. So I need to go around the circle 7 times. in 7 sections. I shouldn't say 7 times. I need to go 7 sections around. So 1, 2, 3, 4, 5, 6, 7. That's where it is on this unit circle. That's 210 degrees. We can also tell just by counting that's 7 pi over 6. 7 pi over 6. So 210 degrees is 7 pi over 6 radians. Second problem done there. Okay, so those first two live on the pi over 6 circle. The next two, I know from just looking at the first one, 5 pi over 4, that's going to be definitely on the pi over 4 unit circle. So a rough drawing there. I know the pi over 4 circle moves around 45 degrees at a time. Each quadrant has 2 sections of that circle. So 5 pi over 4, let's see, that'd be 0 pi over 4, 1 pi over 4, 2, 3, 4, 5 would be right here. So 5 pi over 4 lives right there. Well, how many degrees is that? Let's see, this should be easy. I know that this is 45 degrees. I can't write it, but I can say it. 45 degrees, then 90 degrees. I don't even want to think about this too hard, but that's 135 degrees. 90 plus 45 is 135. 180, I know, is right here. But this angle is 180 plus another 45. So even if I can't do that right away in my head, 180 plus 45, I can certainly do that well enough on paper. That's going to be 225 degrees. Still a little nicer than our Algebra 2 measurements, our Algebra 2 conversions where we used those fractions to multiply. Still works out a little quicker for us, I think. The last one, 135 degrees. Let's see. So I think we just did this. 90 degrees is right here, so it's got to be in this second quadrant. 90 plus 145 is 135 degrees, so the 135 degrees is right here. That's going to be 1, 2, 3 pi over 4. 3 pi over 4. Now, one of the things you'll notice as you get more familiar with these, and you may have noticed at this point, is that both of these circles share some of the same angles. For instance, they all have the pi over 2, the pi, the 3 pi over 2. Those angles are on every one of these circles, both of these circles. The quadrant, I don't know how you'd say it, quadrant angles maybe? The quadrant angles, they are the ones that differ. So some of them are the same, some of them are different. We need to be familiar with both of those, and I think converting those, becomes a little easier once we get familiar with that unit circle a little bit more. So we should at least be able to do this pretty easily by this point.